The emergence of life from the standpoint of physics was, in fact, inevitable. Yes, it sounds very strange. Yes, it may contradict many philosophical worldviews, but physics poses the question exactly this way. Alright, let it be so, but here we encounter a new paradox. We know that the entropy of a closed system constantly increases. Simply put, this means that every process has a certain standard direction, which is in fact what physics tells us. We know that a boiled sausage will always cool down, because that's how entropy works. That is the direction of its arrow of time, and in fact, there are many interesting things we could recall here, but all physical principles agree that the entropy of a system always increases, and the system tends to move from a more ordered state to a less ordered one. But judging by what we observe around us, this doesn't always seem to work, does it? In reality, the question is much more interesting than it seems. And here, a lot of different points start to arise, which essentially boil down to a paradox. Fortunately, these particular paradoxes have quite scientific physical explanations. We come to the conclusion that in order for something to exist, something that we see around us, order is necessary. But we also know that entropy in a closed system, that is the measure of disorder in that system, constantly increases. And here there is an interesting and simple answer. The answer comes down to the fact that, essentially, any of these directions of the process is a matter of statistics, something that is determined by probability and nothing else. And if we recall Boltzmann, who at one time was greatly wronged by everyone, so to speak, even driven to the brink, to some extent, even to a mental institution, he repeatedly stated that the direction of entropy is nothing more than a matter of probability. It is merely a consequence of probability, and the fact that, roughly speaking, time now moves in the direction it does, and a broken cup does not reassemble itself, is just a matter of probability. It is the most probable outcome, but there is a small probability that a broken cup could suddenly reassemble itself. This idea is very interesting. I started talking about statistics for a very specific reason. The thing is, if we try to answer the question of why any ordered structures exist at all, we inevitably run into questions of statistics, questions of probability, questions of the fact that, well, it just happened that way due to random distribution. Why is that? Basically, to begin with, we can reduce everything here to understanding the structure of ordinary materials. What, in fact, distinguishes a metal bar from metal that is, roughly speaking, still only forming somewhere in the depths of outer space? It is distinguished largely by the fact that it has an ordered structure. In principle, this ordered structure is precisely what, in many ways, distinguishes the existence of an object, the existence of matter, from matter that does not exist. These arguments lead to the idea that there is, let's say, a conflict of worldviews, because it seems entropy should increase and disorder grow, yet in local regions structure exists, and material, as we know, forms structure, no matter what kind of material it is. Whether it's metal, whether it's polymer, and so on, it doesn't matter to us right now in order to understand, essentially, the core of the whole argument. This very structure of the existing metal, the structure of the material, would seem to contradict entropy, and it was necessary to find some kind of explanation. Physicists came up with a very interesting way to describe this. Or rather, it's more accurate to say that scientists came up with an interesting way to describe this. It's no coincidence that I mentioned that when we talk about the increase of entropy, we're talking about closed systems. Again, if we proceed from common sense, from what we observe around us, there are no closed systems in nature. And indeed, try to come up with a system that would be closed. You won't be able to come up with such a system. When a kettle heats up, it inevitably transfers heat to the surrounding environment. When a soldering iron heats up, it heats up something around it. There is always some kind of exchange happening between things. Yes, that's how it is. And even in situations where it seems like there is no exchange at all, in reality this exchange still takes place. And the exchange can happen through anything. Ultimately, all of this comes down to the exchange of energy. If there is an exchange of energies, then the system is not closed. And it was noted that since none of our systems are closed at certain scales, in some local zones entropy can decrease. This means that these local zones imply that objects can become more ordered and build complex structures, complex systems that ultimately form everything we see around us. And here, once again, another contradiction arises. It would seem that the universe is a system. What kind, you might ask? Well, a physicist assumes that it is a closed system and therefore entropy in the entire universe increases. But in reality, one of the first turning points that is important for us to grasp is that we do not know what kind of system the universe is. In a general sense, if we proceed from what we observe and look at how most patterns develop, we really can say that this system is isolated and closed. But again, we don't know what is outside the universe, and we cannot rule out that our universe might exchange something with another universe. We also cannot rule out that the universe is part of some complex object that we cannot even imagine, and we cannot dismiss all sorts of strange hypotheses, similar to those we've already discussed on the channel, where we've said that the universe might actually be just an atom, or that we could be inside an electron, and there are a huge number of such theories. Many of these ideas are mathematically formulated. Calling them just ideas is inaccurate. They are already fully developed scientific theories. An interesting question arises. How could it be that, quite arbitrarily, these zones were distributed within our universe? Again, mentioning the troops was no coincidence. Exactly. They are distributed inside our universe in a completely random, non-patterned way. And to some extent, the probability of how this distribution will occur can be calculated. Essentially, this is an expanded answer to a question often asked under the video about the structure of matter, which was recently featured on the channel, and I recommend watching it if you haven't already. It implies that these zones of order were distributed randomly according to statistical regularity. So, what kind of statistics are we talking about here? The statistics are such that they are mathematically predictable, but in essence they are limited to chaos. And essentially, for us, you could say it's random. Randomness, as we remember. There is no such thing as physical randomness. Any randomness ultimately leads to some kind of mathematical distribution. And we remember that chaos, as well as such concepts, have a strict mathematical structure. Therefore, in principle, this distribution of zones was to some extent regular, and to some extent, perhaps it is easier in our current conversation, in our current context, to say that it was random. And here, perhaps, you are already tired of waiting for the answer to the actual question posed, but all this theory is necessary for you for one simple and an important point is that thanks to what we have discussed, we now understand that ordered systems do not contradict physics as such, and essentially nothing prevents materials. From the perspective of modern physics, it is perfectly fine for them to exist. You might say, well, for now, that's how the material exists. There are some ordered zones. Let it all be random, and so on and so on and so on. And yes, we have learned that none of this contradicts science. But how does this actually relate to what life is from a physical point of view? It relates to it directly. The fact is that, in many ways, life as such, from the point of view of physics, it is a function of complex matter, a function of a complex ordered structure. I understand that this, to some extent, raises controversy between those who are proponents of a more philosophical, more humanistic view of the problem, and those who are strictly technical, those who always proceed from some kind of technical knowledge, and tries to see pragmatism in everything. But I want to say that I do not consider myself to belong to either field. I believe that both sides have certain discoveries, certain nuggets of knowledge. Notice, I am not claiming that physics answers the question comprehensively enough. Moreover, science in principle cannot answer this question. And here we have to look for knowledge somewhere in the field of philosophy and related disciplines. And I believe our answer should be somewhat comprehensive. Another matter is that apparently we will not find the answer to this question for now. But in any case, physics should not, so to speak, feel its own superiority here. And you should not feel superior if you are interested in technical knowledge and scientific understanding as such. And you need to be aware that science is not capable of answering these questions. And here we come to yet another interesting question. If that's the case, then why does nature, why does physics, or rather, why does the existing system need to complicate this matter? Why couldn't it have stopped at those very random patterns, those very random coincidences, and those random systems that arise as a result of, and I won't hesitate to use the word again, chance? Why couldn't it have stopped somewhere, for example, at the level of a stone, or at the level of material, or at the level of metal, or something like that? Well, here, physics also has an interesting answer. We said that there is a zone of ordering and a zone of disordering. Yes, again, let's say we are putting aside all philosophical and religious ideas about the question and once more trying to rely only on science and only on physics. And for science, there is such an explanation. And the explanation comes down to the fact that it is advantageous for a system to increase its entropy. Even though we are talking about zones where entropy is limited, even though we are talking about zones where the entropy of the system tends toward a minimum, these are the zones where essentially matter exists, where existence itself is found. Our world, where various cosmic objects exist, still implies that in a closed system, entropy must increase. And we imply that in a closed system, everything should move from an ordered state to a disordered state. And here lies an unexpected but simple answer. It is beneficial for the system to complicate matter so that this thing which will begin to function becomes a machine for increasing entropy. Yes, as strange as it may seem, this very complication is essentially needed by nature in order to achieve disorder. And essentially, any complex object, which, as we have established from the point of view of physics, is what life is aimed at ensuring that the entropy of the system ultimately increases, not decreases. To understand this, take any complex system that is supposed to perform some function and analyze how it actually works. Here's an example with a refrigerator, which is simple and has already been mentioned in my videos. What does a refrigerator do? A refrigerator essentially helps the system maintain high entropy. How does this happen? We have some food, or for example, we want to freeze ice. We take water. Water has a certain structure, and this structure corresponds to the liquid state of matter. It looks like constantly moving, chaotically shifting particles of the liquid, let's say water molecules in the case of water. This system is unstable, it is highly disordered. Next, we take this glass of water, put it in the freezer, and the freezer, by removing energy from the system, causes the system to start becoming more ordered. This ordering causes the water molecules to start arranging themselves in a certain pattern, and this pattern leads to the formation of a crystallized, complex, and ordered system. As you remember, ice has a structure, and essentially, what did the freezer do? It took away the thermal energy from the water, made the particles align in the correct way, and forced the molecules to arrange themselves into certain complex chains. These chains were correct and ordered, and this ordering formed the ice crystals. An ice crystal is, essentially, a properly arranged quantity of water molecules. And so, essentially, the refrigerator in this way created low entropy for us. You might think that such a structure, such ordering, shows us that we can create machines capable of doing just that. In this specific way, by some miraculous means, through expending external energy, we can actually successfully create low entropy states. Yes, that's actually true, but the amount of disorder created by such a system within the universe is significantly greater than the amount of order that this system creates locally. In other words, essentially, a machine that is needed to locally decrease entropy leads to an increase in entropy on a global scale. This implies only one thing. Any refrigerator, any such device created to decrease entropy, becomes a local factory for increasing the global entropy of the entire universe. And it sounds strange. You might say that this only applies to refrigerators, but if you analyze absolutely any device, if you analyze absolutely any system, you'll see the same thing. And absolutely any system, when it is surrounded by other systems, will always exchange energy with them, will always exchange different states, various things, even information and much more. This exchange always leads to the fact that the principle of increasing entropy on a global scale will continue to grow. And the fact that somewhere we obtained crystalline metal implies that somewhere else the amount of disorder became just a little bit higher. But then why do we claim that the emergence of life, from the point of view of physics, was simply inevitable? But we have already discussed several important points. One of the points was that, essentially, for a physicist, life is simply very complex matter. Matter that possesses a multitude of complex functions which often even have a chaotic nature. And this complex matter, in essence, becomes a factory for increasing entropy on a cosmic scale. Here, even if you analyze a few simple examples, you'll see that, roughly speaking, it all comes down to this. Why is that? Well, take, I don't know, for example, any mouse, any living creature, and so on. Any creature, in the end, emits a certain amount of heat. An ordered system emits a certain amount of heat. And essentially, if we're talking on a global scale, some hamster or some mouse, in fact, increases the entropy of the global system just as a refrigerator does, which produces a local decrease in entropy. And essentially, if we rely only on physics, only on the patterns we observe, life becomes a kind of bonfire for burning up the universe itself. strange as that may sound. But doesn't it seem to you that this view is too limited? Doesn't it seem to you that physics by itself greatly narrows our understanding of such complex issues as the very existence of life? And if it seems that way to you, then it really is so. The thing is, physics is a science that is deeply committed to studying the phenomena that occur all around us in the natural world. Getting to the truth is very difficult, and essentially, physical knowledge has only two tools. Yes, no more than two. The first is direct observation, and the second is mathematical calculation. We regularly discuss mathematical calculation, and essentially, when we try to study a certain phenomenon, we build the knowledge we have around a mathematical model. We don't know how, for example, a black hole behaves, we don't know how gravity behaves, we don't know which of these things actually works, but we say that there is a mathematical system that seems to be correct, and then, according to the mathematics that has proven itself to us, we identify patterns. Then we observe and say, yes, here gravitational waves have been detected, here singularity seems to exist, and it looks like some zones have been found in space which resemble black holes, and we say that this is the case. The next point is direct observation. We look at an object and say that this is how it works. That is, we look with our eyes, and where we can see something, where we have enough information, and believe me, there are very few such cases. Even when it comes to talking about the formation of some kind of metal alloy, our eyesight alone is already not enough. And this direct observation often allows us to say that we are getting exhaustive information. When we talk about such, when it comes to global and incredible things like life, we have neither one way to answer the question nor the other. And essentially, you have to agree it's a bit strange to build an understanding of how life as such is formed solely around the concept that entropy is constantly increasing. Overall, if you have been listening carefully, these contradictions are already right in front of you, plain as day. The first contradiction is also the most important one. Who in fact told you that entropy in a system must always increase? You proceed from the idea that in closed systems entropy always increases, and come to the conclusion that, mathematically, that's how it works. But don't you think answering such global questions requires more than observation on a local scale? An interesting picture emerges. We observed that in certain zones where entropy is relatively low, the fact is that outside entropy seems to increase, and then we said that in the entire universe entropy will increase because the system is closed, since there is nothing outside the universe. The very first question that arises here, and is quite appropriate, is whether there really is nothing outside the universe or if it only seems that way to us. Unfortunately, there is no direct answer to this question. But one way or another, this is a serious contradiction. In essence, it puts the dots on the i's and suggests it is far from certain that entropy in our universe is actually increasing, and that this might not just be another local zone we are dealing with, even if mathematically it works exactly this way. But it is possible that a zone where entropy is constantly increasing alternates with a similar zone where entropy is also constantly increasing. And our knowledge here is about as much as an ant occupies on the globe. It is absolutely impossible to speak of any precise or definitive understanding here. And naturally, those who proceed from deeper ideas that life is something far more complex than just a mere machine for increasing entropy, this opinion can indeed be quite well supported and may actually appear much more serious than it seems to us at first glance. The next point is no less interesting. We mentioned that there are certain zones where entropy is indeed low, and we said that all of this essentially is governed by mathematical statistics. But there was also an interesting idea expressed there which deserves attention. We said that based on the work of Boltzmann himself, based on the same mathematical statistics, and purely from mathematics, there is a zone where everything should work completely differently. There are zones where time should flow in the opposite direction, and there are zones where entropy will also work in reverse. And essentially we said that a broken cup that doesn't reassemble itself is simply the most probable outcome. But that doesn't mean it can't happen there. There's still a 100% chance that the cup will just reassemble itself. It's exactly the same on the scale of the universe. That doesn't mean there isn't some interesting zone where entropy works in reverse. That doesn't mean that with our superficial, strange as it may sound, knowledge, with our superficial science, which essentially studies only some indirect science, only things accessible to us, we have somehow managed to answer such a global question. And yes, essentially, why did Boltzmann go mad? Because there was the concept of the Boltzmann brain, which is also worth discussing separately at some point. By the way, give this video a like and write in the comments if you want to hear about that, and then I'll consider covering this topic in our next video. But for now, let's draw a simple conclusion. If something is not mathematically excluded, then it is not excluded. It has a non-zero probability. So can we really say that the entire universe works exactly the way we think it does? We also can't rule out that there are systems in which everything works completely differently. We can't rule out the possibility that somewhere there will be a kind of tipping point where, in fact, entropy will start to work in the opposite direction. And those zones of local ordering might at some point begin to prevail over the zones where disorder dominates. We simply don't have the tools to encompass all of this. We don't have any mathematical apparatus, nothing at all. And essentially, we're working within this kind of closed bubble that we have to deal with. We look at how, roughly speaking, beetles live here on Earth and assume that all aliens must look exactly like that. We see the life that exists on Earth and assume that all life must be just like this. Even better, we expect that all aliens, if they exist, should be humanoid. Moreover, if we look at antimatter, in principle, it does not contradict any of the principles we know, nor does it contradict our understanding of entropy, nor the fact that physics considers life, but antimatter itself once seemed like something paradoxical. And again, starting from its mathematical definition, this antimatter seemed like some kind of, well, flaw, perhaps just a calculation method and so on. And very few people at the time could have imagined that antimatter would actually be discovered, would actually be identified, and indeed would eventually be produced under laboratory conditions. We all remember that story with antimatter. The same thing happens here. Also interesting are these zones where entropy is low. With those specific substances where entropy decreases, materials are formed, matter is formed, galaxies are formed, and so on. But if we turn to mythology, to religion, and to many other sources, we will find many interesting perspectives. We will see viewpoints suggesting that, for example, not specifying exactly what, a higher being by its power and will can cause such zones to exist, that is, to triumph over chaos, over not to be them, and so on. Let's not go into details. I understand that my audience is mostly tech people. I realize that most often those who watch my videos are specifically interested in physics. But you have to agree that this idea doesn't have to be based solely on some supernatural entities. And essentially, it really does seem logical that if someone, by the force of their will, made it happen, that right here everything would be ordered while all around is disordered, that out of this chaos something or someone created such zones, yes, but we can consider this as some kind of physical force that is still unknown to us. And then, in this context, all the logic we have about what is happening once again falls apart. Because we say that there are, yes, states with different entropies, yes. We have a certain system that essentially still tends toward higher entropy. And that essentially life is inevitable because it is beneficial to the universe and helps in this direction, but again, we don't know how this works on a global scale, and it's this lack of knowledge about global patterns leads us to the fact that we don't understand what is happening. Moreover, if we add to this, for example, the absence of time and the existence of everything for an infinite duration, which simply doesn't fit into anything real in our understanding, we come to completely incomprehensible and complex questions for which modern physics has no answers. And if there are no answers, doesn't it seem to you that physics and the questions of life will not be entirely precise? So, even if we set aside the traditional questions like, if the stars are lit, does that mean someone needs it? Even within the strictest science, there are many contradictions that tell us that, to this day, science is not capable of answering such complex and ambiguous questions. But that's another matter for us. Today, we wanted to discuss in what way physics evaluates life and how it characterizes it. And we found that, essentially for physics, life is a very complex matter. We've also discovered that, in fact, life in the universe was bound to appear one way or another. It was an inevitable process. Moreover, it is highly probable and quite possible that at more advanced levels of system development, there will be entirely new types of systems, let's say, much more complex in structure than the systems we are dealing with in the world today. This is an inevitable evolution, but the meaning of this evolution is still not fully or completely understood. One way or another, I think we've mostly answered these questions. And there is an incredibly fascinating point to consider. Even if life is a phenomenally complex matter, and even if life is a system that was bound to inevitably emerge in our universe, despite all sorts of philosophical questions, I truly believe in my heart that this very complexity makes the system beautiful. You know, when you find some interesting mineral or a nugget, you feel a certain sense of admiration. There are many fascinating minerals that you look at, and inside them is an entire complex system. And this system is simply impressive. It's a similar feeling when you look at how life is organized, how nature is structured, and how the universe is arranged. Even if it's a complex system that works like a construction set, even if it's a very intricate structure with many fascinating functions, it's phenomenal. And this phenomenon deserves to be preserved, to be admired, and to be studied. And we will continue to do just that. We will strive to find the most interesting answers to the most difficult questions. Well, today we discussed a very interesting topic, and once again, I decided at least this one time to return to the format that so many of you praised. As you can see, I'm not filming in the studio, but in this magnificent place, and yes, there's Liquid Shield here. Yes, the very system we've been talking about is showing itself at its best. There are many magnificent plants, many wonderful animals, and all of this is both impressive and uplifting. Well, I hope that I have, with this, managed to share a bit of my own, this bright mood with you. If that's really the case, then I kindly ask you to support the video with likes, because that's extremely important. One of the recent videos got rather few views, quite few likes, and that's not good, because in that case I simply won't be able to continue working on this project. So please support the video right now by giving it a like, recommending it to your friends, and of course by watching it all the way to the end, which you've already done. You can also support the channel on Boosty, the link is in the description, or ask a question or send a one-time donation. That link is also in the description. Thank you to everyone who asks such difficult and interesting questions. Thank you to those who are interested in this, and I hope that we all found it interesting to discuss these topics. Until we meet again, my friends, wishing you all the very best, all the best things, and goodbye.